All right, taking a look at number 15, lots of practice problems here for solving either exponential or logarithm equations. And let's just remember that the glue that holds these relationships together is that when you have some exponential base being raised to some exponent, well, if you actually compute that, you will certainly get some result. And so again, we have here the result of an exponential expression where b is the base and the exponent is, well, whatever it is, exponent. Okay, well, in that exact same manner, you then have the inverse of this relationship, which is a logarithm. So log for logarithm. And when you have a logarithmic statement, the base of the exponential becomes the base of the log. And then since it's the inverse, what you input to the logarithm is the exponential result you're trying to achieve. And what the logarithm statement then does is it spits out the exponent that makes that happen. So these are the inverse relationships between exponentials and logarithms, and we're now going to use that in order to solve, well, all of these questions. So if you look at part A, the thing to realize about part A is you have a lot more stuff going on other than bases, powers, and results. You've got this +3 just chilling on the outside. You've got this multiplier of 2 that is neither a base nor a power nor a result. And that's why you always want to start these by simplifying as much as you can that's not a base, power, or result first. So if we subtract the 3, we'll end up with 17 over here. Okay, but there's still an extra value out in front. The 2 is neither a base nor a power nor a result. And so we can divide it off. And then eventually we're left with 7 to the power of x equals 17 halves. Now, certainly you could get the decimal equivalent of 17 halves. It would be 8.5, but you don't have to. You can leave it in fraction form. And so it's at this stage in the game that you're officially in base, power, result form. And so now that you have the three components that you need, you're ready to take the inverse, and that is to write it as a logarithm. So the base of the exponential becomes the base of the log. The result you're trying to achieve becomes the input of that log, and the exponent that is necessary goes on the outside because it now becomes the output. And guys, that's just it. This is now a computable value. You can just go to Desmos and you can say, okay, Desmos, I need to know what power on 7 will make 17 halves. And it turns out the exponent necessary would have been 1.099. So approximately x equals 1.099, or you could round that, I suppose, to 1.1. All right, there you go. Next one. Okay, notice the next one is already a logarithm, but you're still asking yourself about bases, powers, and results. So it's already in logarithm form. You've got the base, the power, and the result. But there's still extraneous information floating around here. Like, what's up with the 4? We don't need the 4. He's neither a base, nor a power, nor a result. So get rid of him. And then we've got log base 5 of x plus 3 is 2. Now, once you get that far, you'll notice this is when it's ready because there's nothing else to undo, so to speak. And all that you can do is acknowledge this is the base, this is the exponent, and this is the desired result. There's no other way, no other math that we can do other than invert it, officially write it in its inverse form, which the inverse of a logarithm will be an exponential. So I'm now going to write it in exponential form, and this is me officially taking the inverse. The base is 5, the power is 2, and the desired result is x plus 3. And now this is something we can solve. 5 squared is 25. Subtract 3, you get 22. Done. Okay, moving on. Once again, this one is an Next up, we have part C. Again, you'll notice that part C is given to us in exponential form, and so eventually we'll need to write it in logarithm form once we have our bases, powers, and results. So let's first get rid of whatever we can. So the -8 is neither a base nor a power nor a result. So let's add it to the other side, making a 22 over there. Also the 9. The 9 is neither a base nor a power nor a result. He's just a multiplier on the outside. So let's undo him as well. So we get 3 to the power of x minus 7 equals 22 ninths. Now you could get the decimal equivalent there if you wanted to, but not necessary. And you might be looking at this now thinking, I'm stuck. No, you're not. You're feeling stuck because there's nothing left to do. You've got your base, your power, and your result, and there's no other quote unquote normal algebra that you can do. That's because it's time to invert the exponential and turn it into a logarithm. So we'll switch to purple as we officially take the inverse. So the inverse of that expression or that equation would say log, the base is 3, the desired result is the 22 ninths, and the exponent is x minus 7. So this expression is just a computable value. You can hop into Desmos and you can find out what is log base 3 of 22 ninths. Well, it is 0.814 if I round it. 0.814. Now, when you do that expression, it's still equal to x minus 7. You haven't totally solved for x yet because it's still x minus 7. So the final answer would need to add 7 to both sides. So you would get 7.814 as your final value of x. Moving right along, part D. This is another logarithm statement. So eventually we will write it in its inverted form. But first we have to break it down into bases, powers, and results. So let's see, what do we have? The -1. The -1 is neither a base nor a power nor a result. So we can definitely start there. So we'll have log base 3 of x minus 4. And now what is that? -2.2. Okay, now this is when you're looking at it and you're like, okay, well, now what? I don't know. I feel like I'm stuck. No, you're not stuck. That means it's ready. All that's left is the base, the exponent, the power, and the desired result. You have everything that you need to write it in its inverse form. Oh, crap. I was supposed to be using blue and then I could invert it to purple. Gosh darn it. Oh, well, we'll do this one backwards. So I'm going to inverse it right now. So my base is 3. My exponent is -2.2 and my desired result is x minus 4. And now you're ready to just finish the computation aspect. 3 to the -2.2, well, I don't know. 3 to the -2.2 is 0.089. Oops. 0.089. And then to finish solving for x, we'll just add 4 to both sides. So 4.089 is the final answer for x. Okay, cruising right along, part E. I'm going to do it right this time where I start with blue and switch to purple when it's time for an inverse. We once again have a logarithm statement, so we want to break it down to bases, powers, and results. And right away, I notice that the 6 is neither a base nor power nor result. So we'll divide that off just because we can. And now we get, what, 3. And now if you're feeling stuck, that's because it's ready to be inverted. You have your base, you have your result, you have your exponent or your power. And so now we're going to write it in its inverse life form. The base is 2.5, the power is 3, and the desired result is 4x. So what is 2.5 to the power of 3? Well, let's find out. 2.5 to the power of 3 is 15.625. So 15.625 equals 4x. And then to finish solving, we need to divide both sides by 4. So I'm going to come back over here. I'm just going to grab this whole thing and say divide 4. And I get 3.906. 3.906. Ta-da! Okay, moving on. All right, what's next? Okay, he's in exponential. He's already in exponential. So he's got bases, powers, and results. But what about these other creatures? They're neither. They're none of the above. The 12. Get out of here. So 8.2 times 1.5 to the power of 3x. What is that? 38. Okay, we're getting closer. But you still have the 8.2. He is neither a base nor a power nor a result. Get rid of him. So now we have 1.5 to the power of 3x equals whatever 38 over 8.2 is. You could leave it in fraction form, 38 over 8.2, or decimal equivalent would be 4.63. So I'll use a decimal equivalent on this one. Okay, and if you're feeling stuck, gosh darn it, I did it again. I'm using purple. Okay, well, that's what I get for trying to color code. Clearly, I'm not good at color coding. Anyways, if you're feeling stuck, it's because that means it's ready. All that's left is a base, a power, and a result. And so now you're ready to write it in its inverse life form, which the inverse of an exponential statement is a logarithm statement. So log, the base is 1.5. The result you're trying to achieve is 4.63, and the exponent is 3x. Now, this whole expression is just computable in Desmos. So let's go figure that out. So we need log, way down here. Where'd you go? Where'd you go? There you are. So log base 1.5 of 4.63 is 3 point, and let's go 3.78. So we get 3.78, but we're still solving for x. Right now it equals 3x, so we'll need 1/3 of this for our final answer. So divide both sides by 3. Come back, Desmos. And 3.78 divided by 3 is 1.26. So 1.26 is our final answer. All right, almost there, guys. Part G. Okay, what we have in part G is they've handed us an exponential. So you have bases, powers, and results. But what about the negative 4.5? He's none of the above. Get rid of him. Divide off that multiplier of negative 4.5. So now you'll have 0.57 to the power of x plus 2 is equal to, well, let's find out. Close out some of this. What do we got? Negative 30 divided by negative 4.5 is a positive 6 and 2/3. All right, so 6.67. And then, okay, I'm feeling like now's the time, right? Because I'm looking at this and I'm like, well, I feel kind of stuck. I don't know what else to do. That's because you have your base, you have your power, and you have your results. You're ready. So the inverse of this exponential will be a logarithm. So log. The base of the exponent becomes the base of the log. Our desired result is 6.67, and the exponent is x plus 2. This is just a computable statement. Hop on over to Desmos. We need the log, where are you? There you are. Log base 0.57, desired result 6.67. Turns out that would be negative 3 point, let's go 38 if I round it. And then to finish solving for x, I'd have to subtract 2 from both sides. So negative 5.38 will be our final answer for part G. All right, last but not least, here we go. Part H. All right, notice that part H is already presented in logarithm form. So eventually we're going to invert it to an exponential. But first, let's make sure we have bases, powers, and results. This negative 3.2, she is none of the above. She's neither a base nor a power nor a result. So we're going to add 3.2 to both sides. So now we'll have log base 4 of x over 2 is equal to, let me fact check this, negative 1.5, oops, negative 1.5 plus 3.2, yep, 1.7, so positive 1.7. All right, now again, you might be looking at that going, and I'm stuck. No, you're not stuck. It just means you're ready. This is your base, this is your power, and this is the result. You've got all the three components that you need to write it in its inverted life form, which is an exponential. So the base is 4, the power is 1.7, and the desired result is x over 2. So 4 to the power of 1.7, 4 to the power of 1.7 is 10.56, 10.56, and that equals x over 2. So x itself must be twice as much. So we will simply times that puppy by 2 and get 21.11 as our final answer for x. All right, there they are. There's your practice section for solving exponentials and logarithms. Hopefully they are starting to click. Appreciate your time and just ask if you need any help. Thank you guys.